We're surrounded by numbers, right? But let's be honest, a lot of the time it just feels like noise. Well, in the next few minutes, we're going to change that. We're going to dive into quantitative research and show you how to find the incredible stories hidden inside all that data.
So, have you ever felt like you're just drowning in data? You've got all these stats, all these charts, but you're left wondering, what does any of this actually mean? See, the hard part isn't getting the data. Nope. The real trick is finding the story that's hiding in there. And that right there is our mission for today.
Okay, so to make sense of all this, it really helps to think about statistics in two big buckets. First up, you've got descriptive statistics. This is all about describing the data you can see, the data you actually have. It's like painting a super detailed portrait of one person. And then you've got inferential statistics. This is where the magic happens. It's about taking that one portrait and making a really, really good guess about what that person's entire family looks like. It's the art of the educated guess, and it's super powerful.
All right, first things first. Before we can start making any of those big educated guesses, we've got to understand the data that's right in front of us. So let's dive into descriptive statistics and start painting that picture. Yeah, you can really think of this as the get to know your data stage. It is the crucial first step. It's where we take what might look like a chaotic jumble of numbers and, boil it down into a few simple summaries that actually make sense.
So where do we even begin? Well, we start with a really simple question. What's a typical number in our group? And for that, we've got three main tools. You've got the mean. That's just the good old-fashioned average you learned in school. Then there's the median, which is literally the value that's smack dab in the middle when you line everything up. And finally, the mode. That's just the one that shows up the most often. Easy, right?
But here's a question for you. What happens when your data has a curveball, an outlier? Imagine this. Most of your gym goers are, say, between 20 and 50, but then you've got one person who's 95. Whoa, that one number can totally skew the mean, the average, and make it seem like your typical gym member is way older than they really are. And that's exactly why the median is so awesome. It just ignores that one extreme value and gives you a much truer picture of the actual middle. Okay, finding the center is great, but it's really only half the story. We also have to ask, how spread out is everything? The range is super simple. It's just the gap between the highest and lowest numbers. But the standard deviation, now that's where you get the real juice. Think of it like a consistency score. A tiny standard deviation means all your data points are best friends, all huddled up together. A big one means they're scattered all over the map.
Look, numbers on a page are fine, but let's be real. Our brains are visual creatures, and this is where the story in your data just leaps off the page. A good chart can show you a pattern in 2 seconds that you might stare at in a spreadsheet for 2 hours and completely miss.
Let's take a look at a simple bar chart. This is your go-to for comparing different categories. I mean, look at this. Your eyes just instantly go to the tallest bar, don't they? It's immediately obvious that losing weight is the biggest reason people are coming to this gym. Fitness is a strong second, but building strength? Way down the list. So simple, so clear.
Okay, now let's slice up this same data a different way. A donut chart like this isn't really about the raw counts. It's all about the proportions. It's about what piece of the pie each reason takes up. And what you see here is that fitness and losing weight aren't just the top two. Wow. Together, they account for more than 70% of all the reasons people visit. Now that is a huge insight if you're running this gym.
Now this might look like another bar chart at first glance, but it's something a little different. It's a histogram. And see how the bars are all touching? That's a key detail. It tells us we're looking at continuous data, in this case age groups. The touching bars show the flow, the whole shape of the data. And boom, right away you can see the story. This gym's sweet spot is the 21 to 30 crowd, and then it drops off pretty fast after that.
All right, so we've gotten really good at describing our data, at painting that detailed picture of our small group. Now we get to the really cool part. How do we take that tiny little snapshot and use it to understand the entire crowd? Welcome to the art of the educated guess.
So, to do this, there are 2 key ideas you absolutely have to get. First is the population. That's the entire group you're interested in, like every single gym member in the whole country, which, is impossible to talk to. So we take a sample. That's a small, manageable slice of the population that we actually study. And here's the secret sauce. The sample has to be random, a truly representative snapshot for any of this to work.
And this is it. This is the big leap.
Inferential statistics gives us the mathematical tools to say something amazing. We can say, hey, based on our little sample of just 500 people, we are 95% confident that the average age of all gym members in the whole country falls somewhere between 32 and 35. Think about that. We're using a tiny piece of the puzzle to see the whole picture with a known level of confidence. It's incredible.
Now hold on, you don't need to be a stats wizard to get this next part. It's just about picking the right tool for the job. You basically have two types of tests. Don't worry about the names, parametric and non-parametric, just think about the analogy. A parametric test is like a surgeon's scalpel. It is super precise, super powerful, but your data has to meet some really strict conditions. On the other hand, a non-parametric test, that's your Swiss Army knife. It's way more flexible, it'll work on almost any kind of data you throw at it, even if it's not quite as precise as the scalpel.
Okay, so we can describe a group. Check. We can make educated guesses about a bigger group. Check. But where the real power comes in is when we start connecting the dots, when we start looking for relationships between two different things we're measuring. Okay, if you remember one thing from this entire explainer, let it be this. Correlation is not causation. Say it with me. All correlation means is that two things seem to move together. It absolutely does not prove that one thing causes the other. The classic example, ice cream sales and shark attacks are correlated. They both go up in the summer, but obviously buying a cone doesn't cause a shark attack. The heat is the real cause behind both.
Here's a perfect example of what a positive correlation looks like on a chart. See how all those dots form a clear pattern, kind of sloping upwards from left to right? It's telling a really simple story. As one thing goes up, the other thing tends to go up too.
And here's the flip side, a negative correlation. As you can see, the pattern is just the opposite. It's sloping downwards. The story here is, as one thing goes up, the other tends to go down. It's a really intuitive idea, right? Like the more hours you spend practicing the piano, the fewer mistakes you're probably going to make.
And this is where things get really powerful. This is called regression. Once we've established that there's a correlation, we can actually draw a single line of best fit that cuts right through the middle of all those data points. And that line, it's not just a nice summary, it's a prediction machine. It means if I know a value on the bottom axis, I can use that line to make a pretty darn good prediction about what the value will be on the side axis.
All right, let's take a step back and look at the whole toolkit we've just put together. We've basically built a step-by-step process for turning a bunch of raw numbers into insights you can actually use.
And of course, let's be realistic. We're not sitting there with a pencil and paper doing all this math. Powerful software like SPSS is the engine that does all the heavy lifting. It runs these incredibly complex calculations in the blink of an eye. And that frees us up to do the most important human job, to look at the results and figure out what story they're telling us.
So, there you have it. That's the whole journey in a nutshell. You always start with a question. Then you describe your data. You use that data to make an educated guess about the bigger population. You hunt for relationships. And maybe, just maybe, you can even use it to predict what's next. Every step just flows right into the next.
So now you have the basic toolkit. You really do. The world is absolutely swimming in data, and pretty much every single data set out there has a story just waiting for someone to find it. So the only question left is, what story are you going to find?